So in this video lecture, we will talk of homogeneous and homothetic production functions. So starting on with, let's talk of homogeneous production functions first. So what are these homogeneous production functions? So first, let's take an example of a usual Cobb-Douglas production function. So suppose your production function is given by y is equal to capital alpha L to the power beta. Suppose this is a production function. Now, suppose the producer increases the input. So you increase inputs by lambda amount. So when you increase input, so that means your capital gets multiplied by lambda and your labor also gets multiplied by lambda. So your new production function that is given by y or say SLK, this is how you represent a production function if you have done the basics. So all you do is you instead of k, you write a lambda k. You raise it to the power alpha because there is a new k which will have the power of the old k. Then you write lambda L and you raise it to the power beta. Now, if you take your lambda out, right? You can take lambda out. The power of lambda would be alpha plus beta. And then again, you are going to have this k, alpha and L beta. So what you see is that your new production function, like if you increase inputs by lambda amount, so this is your new production function. So the production rises by lambda to the power of alpha plus beta. So here in this case, the essential fact that you can see here is you are able to separate this lambda from this k and L. So I can also write this function as lambda to the power alpha plus beta, and I can just write f of k comma L, right? This is how I can write this function. So whenever a function can be represented in the form of, so this is what you did, you multiplied the factors by lambda proportion, and whenever it can be represented by lambda is out, then you have a power n. This n here is alpha plus beta into f L comma k. Then this production function is a homogeneous production function. So is it a homogeneous production function? Yes, this Cobb-Douglas production function is a homogeneous production function. Now let's move to homothetic production functions. We often get confused about these whole things. So let's get the clarity here. So now next we move to homothetic production functions. To understand the true difference, you really need to know the definitions first. So now when we move to this, so now just are you aware of the concept of MRTS? So when we study a production function, the most common concept and the most important concept here is the MRTS, right? So if this is your production function and if you find the MRTS, which is nothing but delta k upon dl. This is the formula for MRTS. MRTS is nothing but the slope of your isoquants. If you're not familiar, you really need to go through the basics of a production function. So if you just do that, now in the numerator, there is going to be, the formula for this is MPL, and in the denominator, there is this MPK. So MPL, how would you find the MPL? You differentiate this production function with respect to L. So this becomes beta L, beta minus 1, k to the power alpha. Then in the denominator, you would have alpha k to the power alpha minus 1 and k to the power beta. So if you solve this, what are you going to get? You are going to get beta upon alpha k upon L. So this is what you are going to get. So what we see here that the MRTS is a function of k by L. So your MRTS is a function. I am denoting this phi. I am using this phi to denote a function is a function of your k by L, right? So when it is a function of k by L, in such a case, we call this function as homothetic production function. So whenever we are able to express the MRTS in form of k by L, in the ratio of k by L, then that becomes your homothetic production function. Now let's try to understand that. Let's take a production function which is homothetic but not homogeneous. So let's try to do that. So as you can see, I have a production function on the board and which is not a purely Cobb-Douglas production function. So all you do is, just like the normal case, just like you check whether it is homogeneous or not, you multiply the k and your L by lambda, right? So when you do that, so you see your A, that is a constant, remains the same. So you just write A as it is plus, you just multiply your k with k lambda k, lambda L and beta, right? So when you do that, what you will find is A plus lambda to the power alpha plus beta, and here you have FLK, that is the same production function. So you see, you are not able to separate this function into lambda alpha plus beta FLK. So there is a plus A as well. So that means this production function is not homogeneous. So this is an example of a production function which is not homogeneous. Now, is it homothetic? How would we check if it is homothetic? We need to find the MRTS for this production function first. So finding the MRTS for this production function, again the formula is MPL upon MPK. So if you find the MPL upon MPK, you would get an alpha upon beta. This is going to be your MRTS in this case. You can solve this, you can differentiate this with respect to L first in the numerator, differentiate it with respect to K in the denominator, and once you have this as a function of, I'm using phi to denote a function of k by S. So whenever you can express your MRTS as a function of k by S, that means the production function is homothetic. So this is a classic example of a function which is not homogeneous but it is homothetic. But remember, it cannot be other way around. So a function which is homothetic doesn't have to be homogeneous, but a function which is homogeneous will always be homothetic. So this function is not homogeneous, but it is homothetic. But if a function is homogeneous, it will always be homothetic, right? So this is something you can learn. So this finishes the topic. We will wind up.